This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio.
Hello, this is Kishore Bhatia for Software Engineering Radio. Today's episode is about the Truffle framework for Ethereum smart contracts and decentralized app development with our guest Tim Coulter. Tim is the founder and CEO of Truffle, the smart contract and DApp development framework for Ethereum. Tim has been full-stack developer before joining Consensus as a blockchain developer, where he created the framework for Ethereum. Welcome to Software Engineering Radio, Tim.
Thank you. Great to be here.
Truffle is known as the Swiss Army knife for development on Ethereum. In this episode, we'll unwrap that statement. Also for the audience, we've covered blockchain and Ethereum as an ecosystem in episodes 297 and 343 earlier. But before we find out more about Truffle, what is Ethereum for you, Tim?
Yeah, so Ethereum is the next stage in computer science, in software engineering. If you look back at the history of kind of milestones in where software has come from, what computing has come from, about every 20 years we have a new invention that amplifies what we can do with computers. In this case, it's a way of tracking value on the internet digitally. When I say value, I mean anything that we could give value to. What this does is now we have a system that can track value between people and interactions. We can actually open up doors that we never have before. Suddenly you see these borders, like country borders or something else interacting with people. You see them quickly fall away. So I'm kind of getting pretty deep there, but to me, Ethereum is new technology that's opening up, different ways of interacting with people across the globe. It's basically you have this global network, you have this global computer, and if there's a way to track value on that computer that's more than just a number in an account, then you can trade with them effectively. What Ethereum lets you do is it's not straight up counts. It's not just numbers in an account. You can actually script those interactions, create new ways of interacting with people. But the barrier gets a lot lower because you could almost trade directly with the person, assuming you are trading inside an internet connected world.
Gotcha. So there's definitely a lot of, digital exchange and digital native use cases that seem, more natural to the Ethereum global computer. Quick question that comes up then is, how do we compare Ethereum to, an existing world of web?
Yeah, so we've set up systems that allow for those kind of things, but it comes with a lot of friction. So I'm going to go straight to the eBay example. If I wanted to sell something to somebody else across the world using eBay is like a third party. So I am relying on eBay to provide a service for me, and that service is to make sure that my transaction between me and this other person actually goes through. So we see in the current Web 2.0 world is we have these third-party services that provide a lot of value, but this puts those companies eventually at an unfair advantage or potentially by using those services to unlock this global world puts us in harm's way. For instance, let's say if eBay gets hacked or PayPal, which is part of that, gets hacked and our information gets taken from there or something else. Or, you've heard all of these stories about people's bank accounts getting frozen by PayPal and whatever else. So what makes this different is that in this case, we've built a system that doesn't need these third parties. The reason that Ethereum and blockchain technology in general is revolutionary is because it provides us systems of incentives for people to act good people together, to act instead of acting against each other. And so, for instance, in the eBay case, you might work with eBay to make a good transactions, and a lot of the times that might work out. But at the same time, you might have somebody on the other end that's trying to scam you. Well, if we can build this system, one of the promises of Ethereum is if we can build an internet-connected world, a blockchain-connected world, then we could potentially have an internet that's much better than the one we have, that's safer and secure and, causes us to be good actors.
So a lot of good points around the eBay example compared to
say having third-party internet services, that accumulated all that unfair advantage over time. Let's just deep dive into the Ethereum stack from a web developer's perspective.
Think about a normal web app. I'm going to go straight to like Ruby on Rails because it's the easiest thing to do. You have some type of front end, some type of back end. You stick the back end, some type of server on a VM somewhere connected to the internet, and then serve the front end from there. And that's your application. So when a user goes to your website and interacts with your app, they're interacting with the front end code that then talks to the back end and has a database and all that stuff, performs some service for you. What changes in the Ethereum world is really the back end. Now, there are advanced Ethereum applications that we can go over at a later time, but generally the easiest way to think about that is to replace the back end with the blockchain. Now, the blockchain is a different computing environment. It's very different from your server. It does less work than you can do on the back end traditionally. And you have to code in a specific way to code for the blockchain. But what the blockchain provides you in this case is that if a transaction goes through and it's processed everywhere. And because of fancy math and cryptography, you are guaranteed that the results of that, the execution of that, happened how they were expected to. So the very basic application, has a similar front end. In this case, it's just a bunch of static JavaScript and HTML and CSS. And then that talks to the blockchain to get most of its data.
That's a great way to put it, as looking at the blockchain architecturally as the backend to all of these web services that we're putting on the front end. If I'm looking at it from an API or a backend developer's perspective, how would you then define the layers on the Ethereum blockchain side?
If you're a normal backend developer for the blockchain, you're going to write some Ruby code or something that's going to be the server. It's going to respond to requests. You're going to use library that's going to make that easy for you. In fact, you might even write your server application to be RESTful and respond to API requests. For a typical application, it's very straightforward from there. What happens in the blockchain world is really completely different. So you are going to write some code that you first need to compile. Call this code a contract. It's a Solidity contract. You're going to take it and make a transaction that puts that code on the blockchain. So remember, this blockchain is like this world computer. It can't run anything if there's no code on there. So it's up to you to put it there. And once you put it there, it's now able to be called. You can now call functions that you wrote and then have it run those functions and store data for you. The process of creating that code and then deploying it to the blockchain is a very different process than writing the server software, for instance, and just releasing a new version of your server on a VM that you control. If you're building a very basic application, it almost makes some things completely easier because you don't even have to manage your infrastructure at that point. The blockchain, again, is a bunch of these nodes running in synchrony. So when you build this application, you put some code on the blockchain. That code has a specific location, and then you can tell your front-end code where that location is. And then once you do that, all you have to really worry about when you're actually deploying your application is deploying the front end that people use. And so it completely changes the game potentially. And actually, to go on a bit of a tangent, what's really cool about this whole thing is that if you have these systems of nodes, we're talking thousands of computers around the world running this world computer, and you no longer have to worry about the back end. Well, all you have to really for uptime, if you're worried about uptime, all you have to really worry about is the front end. And there are even cooler things coming out to complement the processing that the blockchain does. Effectively have blockchain for storage. Imagine being able to deploy your front end on distributed storage that's managed around thousands of nodes across the world. That front end interacts with the back end, which is on the Ethereum blockchain, and suddenly you have an application that can never go down. First off, you have a blockchain client, so some piece of software that connects to the Ethereum network, and it talks to the peer-to-peer network in a certain way. You have libraries that talk to the clients themselves. So for instance, that's Web 3.0, and that's what you'll mainly be interacting with in your front end and elsewhere to make transactions happen. So I like to use this human analogy, and I like to talk about it that way. But it's such a deep topic, and it's you really have to think about the incentives that the users of the network have. And of course, some people are incentivized to just typically do good. Potentially, that's an easy way to say it. Other people are incentivized to work in their best interest. I think if you're a protocol developer, you are building an algorithm that makes people act in their own self-interest, but that self-interest is aligned with the rest of the network. And so therefore, everything works out and it prospers.
That's a great analogy, comparing it with human beings as part of the network of nodes, where every machine, every computer is, as I said earlier, humming along in synchrony. But there's a game theory aspect to it, and the protocol developer is making sure that while you as an individual are still somehow as a human being acting in your self-interest, the common good is maintained, and we kind of incentivize that. Amazing. And definitely you're right, there's a lot of depth to how that is achieved and done. So Tim, going back on our software development lifecycle as we know it from the web world, if I have to look at Ethereum web development, what all are the aspects in the Ethereum stack that one touches? And again, not necessarily one person would know it all, but how is that stack defined?
I think a large amount of applications can be created within this stack. We'll just start very bare bones. You have the smart contracts that you need to write. The most popular language is Solidity. That's a language created by the Ethereum Foundation. It was created because writing smart contracts is very different from writing normal software. To go on a tangent there for a second, literally every line of code, every bytecode of execution, everything that executes costs money, costs gas in the system. Therefore, that's a completely different model of development. Almost no developer in the world is looking at their code in that way, where I need to reduce the lines of code in order to write what I need to write. But in any case, so you start out with the language, and in this case, it's Solidity, and then that gives you smart contracts. Now, you need to get those contracts onto the blockchain. And then the blockchain is going to give you some data back to tell you how to interact with those contracts. So the stack that most developers use in Ethereum right now is the Truffle framework. Truffle takes care of a lot of this stuff for you. So you write your Solidity code, you deploy it to the blockchain, you get these artifacts, which are like the location of the code on the blockchain, what functions exist, specific data about that code, for instance, data that you can use in debugging. We call all of that data artifacts. So you have these artifacts. Those artifacts become your core piece of information interacting with the blockchain from anywhere else. So that is your basis. That is your quote unquote backend. From here, the front end is up to you. And this is where a lot of things differ. So when I'm asked about what's a default stack, it really depends on what kind of application users are trying to build. So you can take these artifacts, these basically the output of Truffle, you can build a web application, in which case you could use any number of frameworks. The most basic library in JavaScript for interacting with the blockchain is Web3.js. You could also use a new framework that we created called Drizzle, which is built to fit with React and Vue.js and a bunch of other front-end frameworks in order to help you interact with the blockchain without really having to deal with all the blockchain details. What I've been describing with these, this is basically a web application. You can take these artifacts and go a different route. Like you can build a console application that interacts with the blockchain. You can build a desktop application. You can even go further and build, like you can take the output of Truffle and build a server application where you have a traditional web server that's standing in front of communication with the blockchain and manages that for users. I've kind of talked about this global opportunities you have. The traditional stack is building a web application. There are a few steps, and these are steps that I went through way back when. So it feels like such a long time ago. This is when right before Ethereum was launched in April of 2015, I was tackling this issue, this exact thing, like what needs to happen, and it's not entirely obvious. So the first thing you have to do is figure out what type of application you're going to build. We're just going to start there. And why I even mention that, and it's not even it's not a tech related thing, is because the applications you build are very different. You could potentially build a system where people interact together and they're incentivized to do certain things. Typically, that may not be the type of thing that you think about. And so if you got a good idea, let's just, for example purposes, go use a generic token on the network, and this token might represent something of value, but let's say it's tradable or something else. And where you start is first off, you have to write the smart contracts. The smart contracts you are literally describing the interaction that other people are going to have together. That might be trading a token, that might be giving some tokens away from to another person, but keeping other ones. You might have a more complex token that you burn some of it, which is a really interesting concept that I do for later. But after you write the contract itself, you compile it, and suddenly you're left with the bytecode of that contract. And now you got to figure out, what do I do with this bytecode? And so the compiler helps you out, but it's still you don't have anything on the blockchain yet. So now you have to deploy that to the Ethereum network. And deploying it is its own thing. Of course, you have to have an account that has Ether on it, and so it can run on the blockchain. So you can put that code on the blockchain, and then you have to make that transaction. And then if you make that transaction and everything about that transaction is good, what happens after that is the blockchain goes, okay, you did that right. Here's an address. Here's where your code lives. Now you're still not there. You still don't have a functioning application. After you've put this code on the blockchain, maybe you create a way of knowing what functions exist, because if you don't call the right function, the contract's just going to be it's going to error basically. So you have to record what functions exist and a bunch of other information, and then you can go try to start writing the front end of your application, whether or not that is a command line or a web application or a desktop application. We're just going to call that the front end. And so you start writing the front end of your app, and that's where you interact with the blockchain from a different side through, if it's a web app, through this plugin, the MetaMask plugin perhaps. And you have to supply that address of that code that the blockchain gave you. You have to supply that to the front end, so the front end knows, well, not only what functions to call, but where to call them. If you try to call a function where code doesn't exist, the blockchain is just going to give you an error back. Your transaction is not going to work. So you integrate that, with your front end. Maybe you've built yourself a pipeline or something to get the output of the compiler to what you're building, and then you go and you build it. You're testing things out, and finally, once you finish, you might have an application that works. Now the thing is that users don't have your application yet, so you need to take that front end at least and deploy that to in some way that users can get it. In the web, you would put it on a website somewhere, and then users would go to, in this case, users would go to your website and run that code, and they would use their own connection to the Ethereum network, and then now you have a fully deployed application. That I described all of that in that way because figuring this out was a mess originally. It was not something that was easy for me to wrap my head around, even though I came from a web development background. There's a lot of, I could describe this in very different ways that makes connections to, existing web development. But the process is really, there's a lot of steps to it, and you could manage that yourself, or you could use Truffle.
The whole exercise, I think the whole experience you just mentioned about, starting from the understanding of Ethereum to writing your first smart contract, compiling that, putting it on the blockchain, even before that, you have to have an account on Ethereum to identify yourself and have that much value to make that transaction happen. It sounds like a very new concept to anyone who's coming from the web world, trying to interact with a backend server, right? The question is, you mentioned a little bit of MetaMask plugin, which is browser based. You also mentioned something about the code that the blockchain gives you, and then the address of the code. Can you just elaborate a little bit on what is that code? Is more like an interface to an API? How do you get that code?
Yeah, so in Ethereum, we call this the ABI. That's actually output by the compiler. So one interesting thing about Ethereum is it doesn't make that information about what code is on the blockchain. It doesn't make that available. So, and obviously that's because it's a compiled language. So you can have 27 different languages that compile down to the EVM, and they don't necessarily have to have functions. Like, functions are an idea that helps us as developers. What it turns into, what the bytecode that you put on the network turns into, is literally an if statement. So you're sending a transaction, and the first this is all kind of like abstracted out for you, but the first parameter is like, what function are you calling? And literally it's just a series of bytes that is unique compared to all the rest of the other functions. And the code that's on the blockchain goes, this is the code that the compiled bytecode has if statements in it that says, is it this function? Or like, is it this identifier? No. Is it this identifier? Is it this identifier? And then it actually goes and runs that. So if it finds a match, it like jumps to the code that represents that function and runs it. So it's super low level. So you don't have that data available to you, which means that you have to rely on the output of the compiler. And the compiler gives you that information. It gives you a JavaScript object that tells you what is there, what's available for you. And then you use that in your workflow to actually call that function later in your front end. And one of the things that you'll end up having to do if you don't use a framework that provides this for you is you're not going to want to be like, okay, I'm going to call the function 0xAE427 because that's like the bytes of it, right? You're going to want to you want to write code that represents the code that you have on the blockchain. That's really like is to say like my contract dot send token, right? So there's like libraries and some layers on this front end to make that experience a lot easier for you. But if you don't use those, you're gonna have to figure that out.
How would you then define Truffle? And I do want to get into like two different definitions. Back when you were like, coming up with this vision, what was Truffle for you?
Yeah. I mean, Truffle literally came out of a need to make my life easier at the time. So came in a consensus and figuring all this out. There's all these steps, trying to wrap my head around this whole stack. Like I needed to build a whole application, not just one part of it. I needed to build, from top to bottom, so I can get an understanding of what this was. And there were all these steps in it, and it ended up where I'm like, well, I'm not going to keep doing that by hand, so I'm going to like write a script for that. And for instance, let's say compiling or something else. And then there's, managing the artifacts, first off, deployment. Actually, I was writing a script for deployment then too. And then it's like, okay, well, after deployment, I need to save some data that I get. So let's write something for that. And then I need to like pipeline that data from the, that comes from the compiler and comes from deployment, pipeline that to the front end somehow. So let's connect those in a specific way. So I built this first project, and then I moved to another one as I finally got a hang of things. And I would take those scripts that I wrote from that previous project and then and transfer them over to the new one. And then there'd always be a new need, so I'd add to that. And then suddenly it just became this thing where it's like, well, shoot, I mean, I'm getting use out of these. I might as well package it up and give it to somebody else. And that's how Truffle was born. So it came out of a need for my own development uses with my own applications, and then turned into a framework that people use. Now it has gotten so much, I'll say A, so much better, but B, so much more advanced. So one of the things, the thing that Truffle does for you, if I was to like completely cut out all the, no pun intended, sweetness of Truffle, and just tell you like brass tacks what it does is it's doing all of the like the gluing and kind of like boring data flow for you. So you need to you need to write contracts, you need to compile them, you need to deploy, you need to debug, and you need to then manage all the artifacts from all that stuff into the front end application that you're building. And Truffle makes all of that really easy. So we manage compilation. It's so weird because back, you might work with something like Visual Studio or something. You press the like build button And like all of your files and code that you wrote is magically just compiled for you, and you don't have to worry about anything. That's the experience that exists and developers are used to. That did not exist for Ethereum. So like you heard me sigh there for a second. Like, we actually perform that work for you. So in this case, all you have to do is worry about writing your contracts and literally just say compile, and Truffle will know what to do, compile that for you, save all the artifacts, and then we provide you a system to deploy. So again, like this object relational mapping, like you want to think about the contracts that you create and them having a place on the network. You don't want to deal with all the nitty gritty like hexadecimal code and stuff. So we've provided a system of deployment that allows you to easily script your deployment steps. That system is heavily influenced from Ruby on Rails, where you have a migration system. So you're migrating the state of the database from one step to the next. So you kind of have that same idea for Ethereum. Anyway, so it's for at least within the Truffle world anyway. So we have these. You can write deployment scripts that are easy to use and map back to the contracts that you're writing, easy to read. Then there's actually a piece of this that I forgot to mention. One thing that didn't ever exist until Truffle came along is actual automated testing for smart contracts. Something you take for granted. Like you move over to a new language. You expect certain things to exist in that language, and suddenly you move over to Ethereum, and 3 years ago, you're like, wait, where is everything? So we take that same object relational mapping, we take that, allow you to write automated tests for it. Not only do we allow you to write tests that you can run your tests against the real blockchain, but why do that? Because the real blockchain is really slow and it's going to cost you money. You could do it against a test blockchain or like a private blockchain. So it's still the same Ethereum client, but still really slow. You're still producing blocks. We've actually built development blockchain. This tech is actually all throughout the products that we built, but it's in our main product, Ganache, but it's also in Truffle in this automated testing framework. You just write the test and it'll run for you as fast as possible. You don't have to worry about the slow block times of the actual blockchain. So we just got a new debugger. This is something that the now lead developer of Truffle, Nick D'Andrea, wrote, and that's another thing that developers take for granted in other program environments, like being able to debug the code that they write. Well, now you can do that with Ethereum. So as you're building your application with all of this stuff that Truffle gives you, we manage the artifact process. So where, what bytecode your code has, where it lives on the blockchain, what functions you can call. We manage that process, and we give you ways to easily plug that in your front end, again, in a way that you don't have to worry about the nitty gritty. You have the object relational model. You're actually using the same code on the front end that you use in your tests and in your deployment scripts. And, we make that whole experience better for you.
Wow, that's a lot of things that are made easier for developers and throughout that journey that you mentioned. I would just say like the two steps that you mentioned earlier, like just compile my smart contract, get it deployed to the blockchain, to the network, get me the address so I can actually invoke functions or I can write scripts against that smart contract and do something with it. That itself would have been like, so difficult back then if you think about not having a framework like Truffle.
Yeah, I maybe should have described it this way in the beginning, but that's what Truffle provides, is literally it gives you the things that you're expecting from a traditional development environment, but in this new Web 3.0 world.
DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio.
So Tim, did you look at any particular frameworks or similar ecosystems that inspired your thinking about why you need to create Truffle, and like how would you go about doing it?
Yeah, so I'll answer the similar ecosystems first. I was heavily building Web 2.0 applications in Ruby on Rails. So before I started at Consensus, and so when I needed to build something myself for the Ethereum framework, or excuse me, for the Ethereum blockchain, I pulled ideas heavily from that. For instance, we have a feature within Truffle called migrations, which is directly inspired from Ruby on Rails, and so that's where in Ruby on Rails you're maintaining a database over time, and so what would use these migrations for is describe changes in the structure and format of data within that database. And you do that through the migrations. The idea being that this structure and format, or your database, is migrating from one state to another over the lifetime of the application. And I thought that when I was building Truffle, I thought that should be the same thing for Truffle as well. So you're treating your contracts or the Ethereum blockchain as the database in this case. It is both the server and the database, but the very basic application, you could consider it to be the database. And so you might want to treat your contracts that you have on chain in the same way. So Ruby on Rails was a huge influence. And then from there, as far as any particular framework, I did look at an existing framework at the time called Embark. Embark had some great things going for it, but some of the design decisions and choices that Embark had built were different from what I wanted. So for instance, I wanted the code that you write for Truffle in all ways, whether or not, or excuse me, not just for Truffle, but for your blockchain application. I wanted that code to be the same everywhere. I wanted you to be able to run tests on not only a test blockchain, but on your a real blockchain, at least a real blockchain client. So, for instance, the Go Ethereum client, you weren't tethered to any particular client. And then there's some other features in there. It's actually, as I'm speaking now, like I have to remember all of these old decisions that were made because since then, Truffle has changed so much. Like we've added so many more new features. We're thinking much bigger than we thought before. So now we're trying to pull inspiration from even other command line tools. For instance, our debugger is pulling some inspiration from GDB.
Can you also highlight some of the challenges as you were creating, as you were thinking about different, features or aspects, starting with maybe the MVP of this, and then slowly, getting to where Truffle became release ready?
Yeah, the biggest challenge, the absolute biggest challenge is knowing what's going to work. So your job as a tools writer is effectively telling users how to do their job. So inherent in the tool that you're creating is how to use the tool, and the how, each step, do this, then do that, and you have a blockchain application. That how is the hardest part. So in designing the MVP and designing other features as they came out, we had to ask the question first off, what would we do as blockchain developers ourselves? What do we want? How do we manage our own applications? How do we want to manage these applications as a team? So from there, it's after kind of designing that, then it's asking, or then it's actually figuring out the actual code. Like how are you going to implement this? And there are some things that help with that, and those are generally those higher level framework choices. So, for instance, as I mentioned, one thing that guided the development was not being attached to any particular chain. Truffle's not. You can run your tests and deploy against any Ethereum-based blockchain or blockchain client, whether or not that's the Ethereum mainnet, some private network, some offshoot of Ethereum. That's Ethereum based. It's all up to you. So we don't have any coupling. For instance, in this example, we don't have any coupling to those chains.
Great. Yeah, that's a thought process. That kind of leads you into many different questions about traditional way of coding. Managing apps, collaborating on source code, all the way up to deploying and testing and debugging that code. in a particular environment. Sometimes you say that it works on my local, and then you take it to define what does that mean, if you deploy it to dev, test and then production. If you were introducing Truffle to, a new application developer with some main features, some components, and maybe an early usage as a getting started, how would you introduce that?
If you're a completely new developer and you're getting started with Truffle, we would likely introduce some of the basic Ethereum topics first. So how the blockchain works, what is a transaction? How do you get code on the network? Those kind of higher level things. And this is actually a really hard thing that we found over time. So we've done some trainings of Truffle and tried to, just from the get-go, we have people in the classroom. From the get-go, we've tried to say, okay, here's the blockchain, and then use Truffle to build the blockchain. And what we found is people don't get it right away. They don't actually make the connection. Why am I using Truffle? They don't understand the pain, to put it concisely. They don't understand the pain of not actually using it. So what we had to do in one training specifically is we had to pivot right in the middle and say, you know what? Let's actually not use Truffle at all, and let's go through all of these steps for deploying applications and building applications on the blockchain, and have you have that experience first. And once they had that experience, then they noticed that Truffle saved them so much time and so much effort. So as far as if I was selling Truffle to you or telling you what it does, the first thing I would say is Truffle at the very least, it's a pain reliever. So it makes your job developing blockchain applications easier. It makes the experience easier. It makes it a lot more fun. It makes the only thing that you have to worry about being your blockchain application, developing, testing, and debugging your blockchain application, the contracts, and the front-end application that you're writing. You don't have to worry about the glue in between, how to manage data between the front end and the blockchain. You don't have to worry about how do you talk to the blockchain. We've got all of that stuff covered for you. But that's just the basics, making it easier. We've added a lot of features over time. One of the biggest ones that I mentioned is one of our newest features. Actually, is the debugger. So as I mentioned, we got some inspiration from GDB. Debugging isn't something that you get from the blockchain by default. When you're debugging, this is something you might take for granted with a different programming environment, where you can write code and then just immediately run that code, stop the code in the middle of it running, and get a bunch of information about it. Like that is almost magical compared to what had existed in the blockchain space when I came on. So we just recently released a debugger. This tells you exactly what's going on during a transaction. It tells you what part of the code you're in. It tells you the variables that your contract is using. It allows you to look at those variables and look at the data that's stored there. Gives you a ton of information on what is actually happening under the hood. So that's huge. So you can technically debug a transaction on any network. Now, the way that we've written the debugger is it actually has the blockchain client execute your transaction again, but it executes it in a way that with the same state that it would have had during when the transaction actually took place. And so what you're doing when you're debugging, we call it a debugger, you're actually looking over the history of the transaction. And this history includes the state at every point in time, every bytecode, every individual statement that gets run, and how it includes the stack information and the state of storage, basically all pieces of information on the blockchain. And this is a history that you could actually go forward and backward in time. So the Truffle debugger doesn't yet allow you to go backward, but we are almost there. We will allow that in a future feature. You install Truffle, npm install Truffle. After you do that, you now have the Truffle command line. What you should do from there just type Truffle init. This allows you to create a bare bones project. Now that's not any scaffolding. What we realized that'll just give you the basic Truffle project with the basic Truffle config, and then the folders that you're expected to have. But what we realized pretty early on is that the applications people were building with Truffle are completely different. Remember, as I said before, not all applications are web apps. You might be building a console application, you might be building a desktop application. You may or may not be using JavaScript at all, actually, for your front end. So what you do next is, I'll say the world's your oyster here. Now, what we've done is we've made it a lot easier to tell users what to do next, but it's up to them to choose what they want to build. And then we've also gotten ideas from the community, and all of this comes in the form of something called Truffle boxes. So a Truffle box is a boilerplate application using specific libraries and tools that will work in conjunction with Truffle that you can get straight from the command line. So, for instance, there's a box that works with React. So you want to create a React web app. In that case, you just say Truffle unbox React, and it will go download that project for you. It'll download it for you, do the initial installation or any other commands that need to be run, and all of a sudden you have a React app that you can start building. So if you go to the Trufflebox website, we have something like a handful of official boxes. So these are boxes created and maintained by Truffle. And then we have about 20 or more community boxes that are maintained by people in our community. So for instance, we have one box, our official box, which integrates Truffle and Drizzle. So Drizzle is our own front-end library that integrates very closely with the output of Truffle. And so we have a box that shows you how to connect the two. And that one is mostly focused on the front end. We have other more general boxes. So React, I'm actually looking through the list now, Webpack. So that would be like how do you use Truffle and create a web application that uses React, or a web application that uses Webpack. But we don't just focus on those things. So for instance, there's a Truffle box called Tutorial Token, and that one is specifically focused on your contracts. How do you create an application that has a token? And this one uses the Open Zeppelin contracts in order to show you how to build those things. It does include a basic user interface, but that one's not meant to show the user interface to you. Or it's not meant to show you how to build a user interface with Truffle. So we have a bunch more. The community has added quite a few of these boxes. I'm scrolling through now, and it's way more than 20. But I would say that given that our community is mostly JavaScript or heavy JavaScript, a lot of these boxes are focused towards JavaScript developers. So first off, compilation. So that is the easiest command. That one itself is just Truffle compile. So if you type Truffle compile, that will pull the Solidity compiler that is distributed with Truffle itself and compile your contracts immediately. So from there, after compiling, in the general workflow of a blockchain application, after compiling and after you've gotten past any compiler warnings, or you think you're ready to run that code, all contract code has to be deployed to the blockchain before you can run it. So this includes any even if you're working on a test blockchain like Ganache, you still need to deploy it in order to get that code to run. So the next part is migrations. Again, that's our deployment framework that sets things up. It's actually based on, or I should step back. It's intended for you to deploy your application to many different blockchains at the same time. So, for instance, you might be working on your local blockchain, Ganache, during development, but you might have also deployed, the previous version to the live network or the Ropsten test network, and you have to manage all of those deployments. Well, if you were just writing your scripts yourselves and being like, you might have to go through the process of the thought process. Okay, what deployment scripts have I run in that chain? what deployment scripts have I run on that chain, what deployment scripts have I run on that one. And we decided that was too much of a burden when working as a team on blockchain applications. So what we decided and how we built this migration and deployment framework is you actually write scripts, but the management of those scripts is actually managed on chain. So as you deploy, it not only puts your contracts and your contract code onto the blockchain itself, but it also says, okay, you have run script number 1. The next time you migrate, there's no need to run that one again. And that's at least, let's say you did that to a test network. Like, you don't need to migrate script number 1 on the test network anymore. And of course, you could override this if you know what you're doing and you've changed things around or something. But it manages your migration state on chain so that all you have to think about is moving forward, so the future of your application. And Truffle will take care of maintaining that future on these different chains as you deploy them. So both the compilation process and the migration process output build artifacts. When you run either of those, you will see this output created in JSON files in your build/contracts directory. And the artifacts that get created, there's one file per contract file. So if you had a Solidity file called mycontract.sol, you would have mycontract.json. And that the JSON file includes, when you compile, it includes a lot of compilation output. So this is gonna be your bytecode. There's actually 2 different versions of the bytecode that have to be stored depending on what you're planning on doing with it. So we store both versions of that. We store other information, so a whole abstract syntax tree. So for any tools, external tools perhaps, that want to analyze that code that created the bytecode, we have that abstract syntax tree. We have something called, we had actually talked about that before, the ABI, in order to tell, in our case, in order to tell Drizzle and JavaScript libraries what functions they can call on those contracts. And we also store, I think we may even store the full source in there. So there's one source of truth, because you might have changed your source file after creating that artifact. But we store a bunch of information. That's during compilation. And then during deployment is when you actually put that code on chain. And once you put it on chain, then it actually has a location. But as I mentioned to you, you might be deploying your application on different blockchains. And so these artifacts actually store the contract address for each chain that you've deployed to. So you might have deployed to the Robson test network and gotten one address. Well, that address is not going to be the same as the one on mainnet. So we store that network information. There's an identifier in there that is able to tell Truffle which network you're using. And then after that network information, it stores the address for that contract.
Does that mean that you would also be able to actually index these contracts somehow, and then I can actually search the state changes and maybe list them down over time?
We don't have a state database yet. That's a really great question, actually. This is just, we are just managing files on the file system. There are, and in some cases have been, some timing issues. So imagine you deploy a version of your contract onto the mainnet that has a certain set of functions, a certain API, and then you later go change that. You go change that API. Well, now your artifacts aren't going to, at least for them as far as the mainnet is concerned, your artifacts aren't going to represent the same API that actually exists on the blockchain itself. So one of the things we're working on is something called Truffle DB that's going to maintain these state changes over time. And this will allow you as a user, but also other developers, to see how these changes have been made and be able to get the state of that contract as it was developed when it was deployed, for instance.
Great. That'll be a huge, in some sense, to be put very simply, although there's more to it, could be also like a good, version management of the contracts.
Yeah, actually. So the way that you kind of get past this timing issue is to use something like Git and be very diligent about that version management yourself. But this will make that much easier. What's really interesting, I guess the one thing that's probably a lot different is the actual address. Like this code not only has this API, but it also has a specific location. And that's a set of data that other development environments don't have to maintain.
What is the config file that you mentioned? Is it a JavaScript, file that I had to go and, edit to create multiple targets, or is there a config file I can change?
Yeah, so it used to be a JSON file. So it used to be just text that you would update, but it became pretty clear early on that people wanted to do some more advanced, have more advanced configuration. So instead of us adding in every feature that everybody asked for, we instead made it a JavaScript file, and you can code in your configuration to do what you wanted it to as part of the initialization process for Truffle. So this config file now, the biggest part of it does what you suggested. It's how do you configure multiple blockchains? Which blockchains are you pointing at? And this file has evolved over time. We're at a point now where Truffle has 100% good defaults for development. So you could not change that configuration. You can have an empty configuration and still develop and deploy on a test blockchain network provided by Truffle, by the way. But after you do that, after you've gotten used to how Truffle works, then you go into the config and say you want to deploy to Ganache to see what's happening, or you want to finally deploy to the test network or the main network. That's when you would go in and change that. There are other options. There are other more advanced configuration options that exist there, but the biggest thing is just telling Truffle where to point at.
Gotcha. And then if I want to do some tests, unit tests, covered as part of my compile and deployment process, what are features in Truffle?
Yeah. So, the easiest command is truffle test. That will run. Actually, the behavior there has changed recently. So previously, you would have had to set up your test network and actually have a test network running yourself. But as I mentioned, Truffle now ships with a test network built in. So you actually have to, you write tests, and these are, it uses the Mocha framework under the hood. What the test runner will do is at the beginning of each test suite, which is a suite is separated by a file. So beginning of each suite, it will deploy your deploy your contracts. It'll run your migrations, but deploy your contracts to the test network so that your tests are starting from a state that you expect. And so these are effectively, it's setting up your tests to run just like your application would run after your migrations are deployed on the main chain. You run Truffle test, and then what it's going to do is it's going to, after deploying your contracts, it will then run each test that you specified. And it does it in such a way, especially if you're using the default test network that Truffle ships with, then it actually uses some extra features we've added to that test network that makes it super quick. So it deploys your contracts at the beginning, but it never has to do that again. We actually snapshot the state and revert back to that state after each suite of tests. So we have done a lot of work to get you the fastest running tests as possible.
So in that, if now, like, let's say we've done the compile, migrations, we've also, done the testing as part of it. And you mentioned that we use Mocha.js framework for the test. What is the debugging like at this point in time? Because you kind of mentioned that the new features that you're adding as a GDB-like debugger. So I think, is that the new state? And how does one invoke the debugging?
Yeah, so the debugger has been released. We're continuing to add new features to it in order to get this debugger to work. First, you need to make a transaction that exists on chain. Now, what that means is that at the current moment, you can't debug any of those test transactions that I mentioned to you because the state is reverted on cleanup. So first, you need to load a chain that will actually allow you to get data from it. And so there's a couple ways to do that. Okay, so you can load up your own blockchain like Ganache, which is a separate program, or you could use a private Go Ethereum network or another blockchain client, or you can use a command within Truffle called Truffle Develop. Truffle ships with its own test blockchain under the hood. Well, Truffle Develop is how you really access that in a way where you can debug transactions. So what it does is it loads up a blockchain for you, makes that blockchain available. I'll get into that in a second. And then gives you a JavaScript console where you can type commands in. And these commands, include all of the commands that you could type on the Truffle console. So for instance, if you wanted to say Truffle compile, in this console, all you have to do is type compile in that case, and it will recompile your contracts from within that console. But it allows you to write arbitrary JavaScript, and we make the JavaScript objects for your contracts available to you. So you could actually play around within this console and interact with your contracts before you ever start trying to write a front-end framework or a front-end application that goes and tries to connect with this chain. To finally answer your question, what you could do is you could use Truffle Develop, make a transaction in there, and then all you have to do is type debug and then the transaction hash, and then you'll be able to dive straight into the debugger.
What is the kind of logging and like log access for developers, both as part of debugging but also, later on if I want to see, what just happened with executing a contract, or if I want to get behind the scenes of an app, like actually doing something over my locally deployed blockchain?
The Truffle application or the Truffle command line tool does provide you some logging. So especially when you're using Truffle Develop, you can use a special flag that will show you the requests that come through and the transactions that are made. However, that might be enough for an experienced developer. If you need more than that, if you need more than the logging that's provided there, I highly recommend that you use Ganache. Ganache is it is that same tech. It is the same. It's the same code that provides you with the blockchain that ships with Truffle, but in this case, it's attached to a desktop application that shows you everything that's going in and out of the blockchain. So not only do you get that same logging about the requests that are being processed, but you also get a view that you can explore about what accounts the blockchain is managing, what transactions are processed, the blocks and what transactions are in each block. And then we have tons and tons and tons of features planned for Ganache. It will connect to your Truffle project and then give you way more information than that. So for instance, you'll be able to click through these transactions that'll tell you the exact function that you called.
For example, if I'm a smart contract developer and I want to bubble up some logs, is there any particular library or method in Truffle or even like Web3 events, log?
So there's a flag for any command that you run with Truffle. You can use the --verbose -rpc flag. And RPC in this case refers to the actual JSON RPC API that Truffle uses to talk to blockchain clients. And that will show you the very low level requests and responses that Truffle is using.
Cool, that helps. Thanks for sharing that, Rick.
One thing that you'll see is that Truffle and the tools that you use are highly correlated. When you're building an application, the tools are highly correlated to the evolution of the actual application that you're creating over time. In this case, the application are those smart contracts. Well, people are building in advanced ways of building smart contracts that add features that the blockchain itself doesn't provide. For instance, upgradability. You can't just, if you want to have an upgradable contract, you don't get that out of the gate. Once you've put code on the blockchain, you can no longer change that code unless the code itself allows for it. So the details on upgradable contracts get very complex, but what we're likely going to do in the future is provide one or more different upgradability options that are tightly integrated with the deployment workflows that Truffle provides you.
So how do you iterate over an app development with Truffle with something that is already deployed? The question is primarily towards change management and pushing things to prod.
Yeah, so that's something that we are currently working on now, or I should say we're heavily working on now. So to give you a bit of background, let's start with an application that you are creating. Let's say you haven't deployed it anywhere. What you'll do is You'll first work on your local development blockchain. This is where you're going to make a lot of changes back and forth until you are happy with those changes. So one of the reasons why you're going to want to work on your local development blockchain is because it's super fast. But after that, you might decide the decision after you've gotten the contracts to a state where you're ready to deploy, the next decision is really up to you and up to your team if you're working on a team. And that decision is, do I deploy to a test network? For instance, like in the Ruby on Rails world, you might call this staging. Do I deploy to a staging environment where other people can use those contracts and interact with them? And so we can test that out first. There are levels of staging, by the way. There's staging. Maybe you set up a private network just for your team. That's fairly easy to do. Or you can decide to use something like the Ropsten test network, which is a global test network. You can decide to deploy to that. And then after you kind of make that decision on whether or not you go to staging, from there, you then decide to go to the main network. Now, this lifecycle, the difference, well, actually, let me get really detailed. If you want to do that, you will have described these different networks in your Truffle config. And these will tell Truffle how to connect to each one. But after that, the steps that you need to take in order to deploy are actually super easy. All you have to, for the first one, you might say Truffle deploy or Truffle migrate. Those are the exact same. They're an alias. -- network, and then say, in this case, staging. Or it really depends on how the exact name that you use there for staging, like for in this example, staging, that depends on what you've put in your Truffle config. But you might have an entry in there for staging, so you'd say -- network staging, and then you might say -- network mainnet. But where this gets you is this gets your contracts deployed, and then you can deploy your front end application, however you're going to deploy that. And now you have an application that you can release to the world. This is where things get tough. As I mentioned before, one of the properties of the blockchain is that once you put code on it, you can't change it. So currently with Truffle as it stands now, you have to code in your own application lifecycle once you have deployed your contracts once. And that could look very different depending on what you want. So for instance, you could build your application in a way that has a dumb proxy contract that stands in front of your actual contracts, and you just update like where that contract is pointing to. That's one way to do it. That's a really easy way to do it. But you might also do more advanced things where you have a contract that gets requests or transactions coming in and knows how to translate them to the underlying code. There's very complex strategies you can use, but the strategy you choose is going to determine your life cycle here. Now, the thing is that where Truffle is currently failing is telling users kind of how to do this, like what's the best way to do that. To kind of go back to, as a tools builder, you are responsible for kind of guiding users into how to do their job, or the best way or the easiest way, or perhaps the default. And I think one of our major tenets is like, we will give you a good way to do things, and if you want to do something more advanced or complex, that's your choice and you can choose to do that. We won't block you, right? But we're hitting a critical mass of developers that need these features, that need kind of guidance on how to manage this change lifecycle once you've gotten to version 1.0. So we are actively working on that now.
You mentioned that a lot of that, maturity is coming in now, that the framework is getting battle tested, and maybe more and more applications that are going mainstream are actually using and demanding that maturity. Are there examples where you've seen some of the teams that are out there reaching out, and like how do they engage you today?
That's a great question. So our work exists in kind of two different tracks. One track is building up the tools that developers expect to have from all of the existing environments. So for instance, a debugger or package manager, right? Like we're working on that. At the same time, we have another track, which is being reactive to the community and building the things that they ask for, or building it in a new Web 3.0 way. So in the past, we've worked with Shapeshift. They helped determine the features of Truffle 4. They were our big VIP user in that case. This time we're working very heavily with Colony for Truffle 5. We do get a lot of feature requests on GitHub and from within our community, for instance, from within the Gitter chat. But what we generally do is find one or two or perhaps a few people we call VIP users, and then we use them to help inform the next version of the tool. We actually have a really good relationship with Colony. We have a Slack channel, a shared Slack channel with them. One thing that we want to do, and I'm really glad I'm able to say this here, is that we want to create these VIP relationships with a lot more people. So people listening to this podcast, if you would like to have a close relationship with the developers on Truffle and you think that you can help guide the next version, we would love to talk to you.
So like what, and you were definitely getting there into the evolution of Truffle and roadmaps. And thanks a lot for like actually capturing some of the evolutionary changes as we were discussing, the key features, as we were discussing the deep dives. Anything else on the evolution, since the beginning that you'd like to highlight, especially also things that you'd want to call out on the roadmap?
So we talked about the change management lifecycle. One thing that's really important to that is deployments. So I mentioned that we're going to be working on upgrading. That's not there yet, but we wanted to do some things with Truffle 5 that would kind of preempt that. So the thing is that when you're deploying, especially when you're deploying to the Ethereum mainnet, you are spending real money, in some cases hundreds of dollars, depending on how much code you're deploying. If that goes wrong, and it could go wrong for many different reasons, for instance, if the network is under heavy load, but if that goes wrong, you could be out some of that money. And the thing is that it's kind of like pressing the button when you deploy to a live, like when you run your Ruby on Rails migrations against a huge live database. You're like, yes, you spent a bunch of time testing it, and yes, you ran it on a staging server, but you're still finally, once you deploy it live, you still have those butterflies in your stomach, and you're going, is it going to work on the live database? And one thing that Ruby on Rails gives you is that because your database doesn't necessarily hold the same property as the blockchain, you can revert back, but you can't necessarily you can't do that with the blockchain. You can't revert a transaction. So it's a lot more anxiety inducing, and we are using Truffle 5 among all the many other features. We are spending a lot of time to reduce that anxiety. I've mentioned Ganache, and Ganache makes developing a blockchain application a ton easier, and basically it's what it provides you is it kind of opens the black box that is the blockchain. So you might, as a developer, you're going to have an experience that starts out, obviously you're going to try to have that best experience with Truffle. You might use one of our Truffle boxes that gets you an application running, from zero to 60 in no minutes flat. But that is still going to involve a certain amount of magic. It's still going to take time for you to understand exactly what's going on when some of the basic stuff, the basic blockchain development things, like making a transaction. What does that mean? Or understanding how Ethereum works and a block, holds many transactions, or understanding what gas is, for instance. Well, Ganache tries to open that up for you, and you can see exactly what's happening in real time. So I think I had mentioned we have a lot of updates there. The thing that we're going to do immediately is something called contract introspection. So that's what we're calling it internally anyway. And contract introspection means, okay, you are working with Ganache. If you are working with Ganache, how do we connect your Truffle project to take advantage of all of that juicy information that's stored in those Truffle artifacts, and then display that to the user in a really nice way? So I kind of got to it a little bit before. I'm like, okay, we can tell the user what functions were called. We can tell the user what variables were sent along with it. We can show
if we go back to that idea that I talked to you about of Truffle DB, if you can know we have all that artifact information over time, then we can show users throughout their whole development session. We can show information about all of those contracts, even the ones that have changed. We can provide an interface for interacting with the storage of those contracts in a visual way. We can show events. Events are a special thing in Solidity that allows you to get information from the blockchain in a special way. So we can have an event browser that gives that information. Then finally, we can have a visual debugger, which is something that we can't wait to do. And this will integrate with the underlying debugging work that we've done for Truffle. So that's something that we have on the list for Ganache. There's actually one more feature that I really want to tease out, which is something that we're working on. One of the things that we can do with Ganache is actually have it where during development, you are developing on the main network. We've built this technology already, and all we have to do is integrate it. But with one click, you'll be able to develop with all the code, all the data, and all the accounts that exist on the main network without having any of that information actually make it back. So for instance, you can deploy and make all the transactions that you want without having it cost you any real ether. One that I haven't mentioned is Drizzle. The biggest thing that I'd like to mention for Drizzle, besides being what it is, so Drizzle is a front-end framework meant to fit in with React and Redux. Actually, not just React. It's Redux. It's Redux-y, but it can work with Vue and other front-end frameworks. One thing that we are really working toward there is making the whole experience easier for our users. So not just for developers themselves, but the users who are going to access their applications online. The main feature that I'm talking about is effectively making the blockchain feel a lot less like a blockchain. And what I mean by that is when you run transactions, you generally you make a transaction, you approve it, you wait 15, 20, 30 seconds in order for that transaction to process. And then your application updates, or the application updates, and then the user can use it again. Well, we're working on this feature called optimistic processing that will run your transactions under the hood in a special blockchain that Drizzle will provide you. Show the state as if they ran on the main chain, and then wait for the main blockchain to catch up. So it's there's some experiments that I think we need to go through in order to get this right. But if we do it right, we could drastically change our users' experience when they use our applications.
Definitely looking forward to how some of those new experiments pan out, and Truffle 5 looks like something that folks must try. Just to also call out maybe the mainstream catching up of the the blockchain systems and ecosystem, and then how we can actually make that end-to-end UX development as well as the user experience for the end users a lot more smoother, maybe seamless, as you mentioned about this state change that is happening, and then somehow we are able to still simulate and predict that. I think towards the wrap up, like what's your go-to reference for all the things blockchain, decentralization, specifically even Ethereum technology?
My go-to reference every day is just the Ethereum subreddit. That has always been the place that, for me, has had the most interesting news and up-to-date information. That subreddit has kind of evolved into that used to be like the place in like 2015. When I say like the, I also mean like the only. So that's evolved into a couple different subreddits now. So there is EthDev is a big one. That one you'll find me and other people hanging in there quite a bit. That's a good reference for new blockchain developers. Beyond those two, I think that's mostly it for me. That's where I keep on most of my biggest news about what's happening in the blockchain. Actually, I take that back. It's that and crypto Twitter. So crypto Twitter is just regular Twitter, but with all the crypto people on it. So I've kind of established a bunch of crypto people to follow. You can check out my followers list if you want. That might be a good use for people. Now, if you're asking me where you should go to learn about Ethereum or if you're new or you want to learn about how to program for the blockchain, the first place I'm going to say is check out Truffle's tutorials for the Ethereum overview. So we have one focused solely on Ethereum itself. It doesn't require you to know anything about Truffle. And then we have a pet shop tutorial, which that one actually goes through the whole process of downloading, installing, and using Truffle for the first time. So those are the main things. I would also, if you're looking for a Solidity tutorial itself, this is where I'd go back to Loom Networks. Their Crypto Zombies set of tutorials is a really good piece of information. My go-to reference every day is just the Ethereum subreddit. That has always been the place that, for me, has had the most interesting news and up-to-date information. That subreddit has kind of evolved into that used to be like the place in like 2015. When I say like the, I also mean like the only. So that's evolved into a couple different subreddits now. So there is EthDev is a big one. That one you'll find me and other people hanging there quite a bit. That's a good reference for new blockchain developers. Beyond those two, I think that's mostly it for me. That's where I keep on most of my biggest news about what's happening in the blockchain. Actually, I take that back. It's that and crypto Twitter. So crypto Twitter is just regular Twitter, but with all the crypto people on it. So I've kind of established a bunch of crypto people to follow. You can check out my followers list if you want. That might be a good use for people. Now, if you're asking me where you should go to learn about Ethereum, or if you're new or you want to learn about how to program for the blockchain, the first place I'm going to say is check out Truffle's tutorials for the Ethereum overview. So we have one focused solely on Ethereum itself. It doesn't require you to know anything about Truffle. And then we have a pet shop tutorial, which that one actually goes through the whole process of downloading, installing, and using Truffle for the first time. So those are the main things. I would also, if you're looking for a Solidity tutorial itself, this is where I'd go back to Loom Networks. Their Crypto Zombies set of tutorials is a really good piece of information.
Great. I'll include these links. Thanks a lot for many different details here, especially talking about your experience and reference guides, as well as a new getting started with Ethereum, Solidity, and Truffle. How does one reach out to you?
Yeah, so me specifically, the best way is really through email, and this is basically anybody on this list is going to get the direct access. So it's tim@trufflesuite.com, and that's really the most direct way. Now in 2018 we have tons of different messaging applications. The Gitter channel used to be the best way, but now there's over 4,000 people there, so it's hard to get a hold of me directly there. So email is good for me. Gitter, you can still see some of the Truffle devs there. If you have a team that wants to be in better contact with us, we, as just all of Truffle developers, we could consider setting up a shared Slack channel, which is super helpful for us. And then if you have any business inquiries or anything else, there is a inquiry@trufflesuite.com email address. And then, of course, if you have anything, I think I'm required to say this, but I can't believe I forgot. If you have any type of bugs or feature requests, please direct those to the GitHub, the associated GitHub repositories for the library or application you're writing in about. So for instance, if it's Truffle, you should go to github.com/trufflesuite/truffle.
Great. Tim, thanks a lot for spending the time to deep dive on Truffle and the overall ecosystem with us. This was definitely very helpful. Lots of things, and hopefully in some time we can look for what's coming next with Truffle 5. Thanks.
Absolutely. And thank you for having me, Kishore. This was a great time. I really appreciate it.
DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.